Hello. I wanted to make some notes about homework 5 as people are working on it. I've peeked at some of the work that people are committing to GitHub, and there are some things that I see that I just want to clear up for everyone so that there is no doubt about what is the right thing to actually be doing, or what are some of the mistakes you could be making. One of the things is yeah, you'll see in Campus Wire, someone asked about the entity relationship diagram, and I gave some feedback on that. There are multiple designs that we could come up with for this problem of a shopping list that contains a set of items. Now, based upon the features of the program that I said that it needed to support, again, I actually believe that what we have here is a situation where we can create and delete shopping lists. And so they can exist without anything on them. I create a new shopping list and nothing's been added to it. Then, given a shopping list, I can add items to it. I can remove items from it. All right. So items on the list are always with respect to a shopping list. Nothing in the application says a user should be able to create an item and store those items somewhere and then later assign them or remove them from lists. No, it's all about you given a shopping list, you're adding items to it. So those items never exist on their own. All right. With that in mind, we end up with an ERD where you've got something like, you've got a, let's say, shop lists. And we said we're going to give them a unique auto-incrementing ID as its primary key. I asked you to do that. I also asked for them to be plural as a good habit to help us as we head into Rails. Then you've got your items, let's say, that you're going to add to your list. You could have an ID, and if you wanted to, you could call it name, or I might choose something like description just to make it a little bit different. I name my list and I describe the item on my list. You can do whatever you want, though, of course. Then, there's some sort of relationship between these two to connect them. All right, these are our two entities, and we could basically, we could end up doing something like, item underscore list as the connection. So we always just go ahead and draw the lines. Then we need to ask ourselves some questions about the cardinalities and also issues about participation in the relationship. So given a shopping list, I know a shopping list is going to have 0 or more items. And so this notion of a line with no arrow on it is a correct representation of 0 or more for shopping lists to items. So that's good. Items, I'm going to have a single item here, and it's going to map to one and only one list. So the item will never exist without the list, and it will map at most to 1. So those are two things. So mapping to at most 1 means I stick an arrow here. Okay? Mapping to at least 1 means items totally participates in this relationship. There's not a single item that is not part of this relationship. And so we turn this into a double line. All right. So items is totally participating in this relationship, and one item goes to one shopping list. One shopping list can go to 0 or more items. All right. So this sets up our entity relationship diagram as I think makes sense based upon the problem and the functionality the application needs to support. All right, then you need to turn this into a schema. So you go, oh yeah, I got to make a schema. So of course, it's always easy to do the entity lists. We take the entities That's the name of our relation. And we just basically transcribe them into relations. Great. Then you've got your relationship set. Now, one of the things that really bothers me is that I see a lot of people. I gave an example for the laboratory for the homework, and people copied that example. Now, obviously, you're supposed to be copying something from it, but they just whole on copied it. And they completely threw out the portion where they asked themselves, is this the thing that I should copy? Has he really given me the complete answer and all I need to do is change some words in it? And the answer is, no way did I just give you the complete answer and all you're supposed to do is change some words. Okay, no way. I mean, the example, and my apologies for not making it clear, the example was to help you very quickly recognize the components of a SQL create statement so that you could reuse those components as necessary to build up your own SQL create statements. So you could see things like, oh, how do I do an auto-incrementing primary key in a table? All right, it's a serial whatever in PostgreSQL. Oh, I need to be able to specify what the primary key is. Oh, I can do that here. Oh, I need to note what the foreign key constraints are. That's how I do the foreign key constraints. Oh, how do I say something should be not null? There's how I do it, you know. What should I do? What's the type I should use for these strings? Oh, okay, there's the type that I should use. Not, please copy the whole doggone thing and change the names. Because it led people to do things like this then, when they did that, where they went and they go, all right, I've got item list. Great. And in his example, he takes the key here, and he has them as primary keys. And so, okay, I'll call this shop list ID. I'll call this item ID, and I'll underline both of them. They'll be primary. Both of them together will form the primary key. But in my example, it's a many-to-many relationship. In a many-to-many relationship, this is what we do. We together, both of them form the primary key. In a one-to-many relationship, it's the one side of it that forms the primary key. All right. And in a one-to-one relationship, either one forms the key, if I recall correctly. So that is wrong. So don't do that. So it really would be item ID would be the key. And the reason being, again, one item goes to one shopping list, so a single item ID is able to identify the unique row, because there will only be one row in this relationship set per item, because there's only one item going to one shopping list. All right. So that would be the primary key. But you should then immediately also say, absolutely, and you're expected to know this, that total participation, when I have one item here going to one item there, aha, I can do a schema reduction. So this table here, this relationship set, can be combined with this, this is supposed to be plural, sorry, this relationship set here, items, all right? And it's again because every single item ID here is connected to one and only one shop list ID. So we can put the shop list ID into the relationship set here and be done. So we're going to cross this off, Cross this off. We're not going to have these guys anymore. And we're going to do a schema reduction where we're able to condense to ID, description, shop list ID. And we're going to say foreign key is, I'm just going to draw an arrow to the shop list ID right now. You should spell out that foreign key, shop list ID, references, shoplists.id, okay? So the great thing here is now you only have 2 tables. It makes your life better to have fewer tables. Things are easier, all right? Just think about writing SQL statements. Oh, it's not as much work. I don't need to deal with 3 tables when I join. I only need to deal with 2 tables when I join. That's good. So yeah, this also makes another part of the homework easier then when it comes time to actually, for example, add a new item to a shopping list. So again, we don't make the item on its own. We add it to a shopping list. Well, the neat thing is that if you've got, again, if you've got items, and this ID is auto-incrementing, look at how easy this becomes for you. You're given a shopping list ID, you're given a description for the item. Now you can put something into that list in a single insert statement. So you insert the description, you insert as a value, and then you insert as a value the shop list ID, and you don't specify this ID, and it gets an auto-incremented value, and you're happy and you're done. Now, some students aren't doing their schema reduction, and so now they have a head scratcher, which is if they haven't done the schema reduction, so they've got this, and then they've got, I guess, item list, and I had a item ID and a shop list ID. I've made my item ID the primary key. Now they have the problem. They know that they've got to add an item. It's going to get an auto-incremented ID because they're not setting what the ID is. And how do they know what that ID is? To be able to then go put into the relationship what the correct ID is. And so you end up with some incorrect approaches to this. So the worst is to see someone do the following. So this is, I'm going to put this is wrong. Not wronged. This is wrong. This is bad. This is never do this. This is, hey, I bet I'm going to put it on the exam to make sure that you never do this. All right. So wrong, bad, never do this. What are they doing? Well, first step, they do, they insert an item into the items table. Great. But they don't know what its ID is. So then 2, and they go, well, they do know that this description, on one list it could be bananas, on the other list it could be bananas. On one list it could be screwdriver, on the other list it can be screwdriver. So selecting by the description to find back what the ID was is going to be a no-no. It's not going to work. They're potentially going to have a mistake there. So they say to themselves, well, this is what I'm going to do. I'm going to do the following. I'm going to select max ID from items. Aha! They're going to do this, and then they're going to use, and let's just say they say ID is equal to this. And then they're going to use ID and insert into their relationship set, which is item list. So what's wrong with this? I highly suggest you pause the video, you think about this, figure it out, spend at least a minute thinking about it if you're having trouble, and then resume the video. All right, so you probably did not pause it because you're human. You probably, I don't know if you've thought about what's wrong yet, but I'll tell you what's wrong. You really should be able to think about this. Remember, our databases are designed for concurrent access. Our applications often are going to be built out as web applications. We hope to have someday thousands of users. Okay? Yes, I've said that the system is a single user app and the user should be smart, probably. But you know what? If that user inserts one item, you know, they do this, but at the same time, for whatever reason, they're running the command in another terminal. Exactly, they hit the button at the same time. I don't know. It's unlikely that they're going to do that. So maybe under your notions of, oh, it's a single user app, this will never happen. But this sets you up for being unable to actually code correctly for the real purpose of all of our databases, which are dealing with multiple users concurrent access to the data. All right. So in that scenario, you're running this and someone else is running the same thing at the same time. And now a race is on. All right. So we're going to have, this is what's called a race condition. So a race condition is basically, oh my goodness gracious, I never freaking want to have a race condition in my code. Basically, it means whoever gets to somewhere first, you know, gets it right, and the other person gets it wrong. And in fact, unfortunately, yeah, so one person's going to win, one person's going to lose this race. So one piece of code is going to work correctly, and the other piece of code is going to be broken. And it's both the code is broken, but the result, one person gets the result they expected, and the other person gets a bad result. Actually, this will lead to inconsistent databases. What happens here? So person A is running this, and let's say we have, you know, the ID sequence, whatever it is. Let's say it's currently at 1. So the person's inserts the item in there. It goes to 2. The other person running the code runs it as well. And remember, there's only one sequence. The whole point is to get unique IDs sequenced out. So the next person goes and they run and they get a 3. Now this person runs and the max ID is 3. The other person gets a max ID of 3. This person inserts 3 and the item list. The other person inserts 3 and some other item list. Wait a second. Whatever happened to item 2? Item 2 is lost to the wind. Item 2 just floats forever in the items table, never being connected to a list via the relationship set. This is not good. No. This is like the worst way to do it. All right. How should we do it? You're like, stop telling me what not to do. Tell me what to do. I agree. Absolutely. First of all, if you didn't have this relationship set implemented this way and you had done the schema reduction and you had that as a foreign key, you'd never be able to make that mistake, because you couldn't ever make an item without assigning it to its shopping list. So if you attempted, the foreign key constraint would flag it, you would get an error, and you would not be allowed to do your insertion. This way, so in other words, this is also, as we design our schema helps us program better and not make mistakes. So do that schema reduction, set that foreign key constraint. All right, but let's say you still want to be able to find, you want to be able to insert and find out what that ID is, because it would be nice to know. So how can you do an insert and find out what that ID is? Because it could be really useful. I will tell you that when we get to Rails, which we're going to talk about very soon, we're going to have an object relation mapping. When we have this object relation mapping, and we go and we decide to save or create or whatever these rows, that object that we will have in Ruby representing, let's say, an item, will always know its ID. And we can just ask it, what is your ID? And that's really convenient and easy then. And so that problem is solved for us. Now, if you're using something like this SQL, it's going to be a little bit different. Why are we doing it this SQL thing? Because I want to expose you to more than one way of talking to a database. Yes, we can write SQL with PSQL as our command. We can run scripts and stuff, and that's all well and good. I wanted you to see, yes, from regular programs, there are different ways to connect to databases and run queries and get results. SQL, with the way that we showed, where you put in a query and you get back a row set, is a really traditional format of operating and talking to databases. And I wanted you to be able to see that and think about that as a way to do programmatic access to the database. What we're going to do when we get to Rails, again, is we're going to have an object relational mapping. And that is a totally different way. It's very commonly used in web frameworks, and you'll get exposed to that as well. So you get this whole complete suite of how do I connect and talk to a database from a programming language, or, you know, in the case of PSQL, how do I just run SQL commands and get results, which is not from a programming language. Anyways, if you're doing it in SQL, not the language, but in this Ruby gem, if you were to do something, I'm going to be going back here to my books database. So I insert the book, and I've got this DB, and we can write an insert statement here. You know, we can insert into, you know, books, blah, 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 blah. You got some statement there, you know, and we're going to fill it out with values and so forth and so on. You do this, and then you have to tell it, please actually do the insert. Okay, so you say, yep, do my insert for me. The problem is this guy here always just simply returns nil. All right, no matter what you do, there is a SQL statement that's really nice, and you can play around with this, where it goes and it continues on, and then at the end of it you say returning ID. All right, and so you've got this insert. It does the insert, and of the row that gets inserted, it says, oh, can you give me the ID column of that, please, and return that as the result of this statement so I can find out what the ID was? That's pretty cool. That's great. You would hope that this would work. This still will just return nil for you in the Ruby gem SQL. So it makes you want to go, no, don't do that to me. So the solution is that you're supposed to be supposedly doing it as instead as ID is equal to DB. You specify the table name, books, and you call .insert, and then you get to name your columns and give their values. And so, you know, I've got a title column, and I go title colon, and let's say I had let's just say this is, you know, I'm just going to put in a string title, and I do author colon, I have some author. All right, this, when it runs, the Ruby gem SQL says oh yeah, you're doing an insert, and oh yes, I notice you have a primary key auto incremented. Oh, it does all sorts of just smart, intelligent stuff, and it will return you the new ID, and it'll end up in this variable, and then you could use it. Okay. So homework 5 though, because so in other words, let's just pause for a moment. So as we work to connect to databases, programmatically access databases, and so forth and so on, yes, there's probably a solution to whatever problem that we have. We can find some way to use, when we're using that, gem or library or whatever method we're using to connect and talk to the database to actually solve the problem that we're having. In the Ruby Gem SQL, this is really the way that we're supposed to be doing our inserts. I didn't introduce that in the previous homeworks and things because I just wanted you to be able to use your SQL statements. And what I made the mistake on in homework 5 was assuming that everyone would eventually get to the reduced schema and with the model that I envisioned for it, and thus you would be like, it's easy. All I do is I write one insert statement, I give the item its description, and I specify the shopping list ID, and it's inserted, and I never need to worry about what that ID was that was created. But for those of you who didn't do the schema reduction, you're faced with how do I get that ID? And you haven't been told how to do that, and so you invent. You should be congratulated on coming up with thinking, I'll take the max. That's a good idea from the stance that I'm proud that you figured out a way to solve it. But unfortunately, if you were to ever do that, you would set yourself up for destroying the ability to do concurrent usage of a database. And so I don't want you to do that as a solution. That's why I'm spending all this time right now doing this extra bit for lecture with the video to make it clear that selecting max ID is a big no-no to find out what your last inserted ID was, because you're in a race condition with other people doing the same thing. This is the correct way. If SQL supported that Ruby gem supported this would be the way to do it. And again, when we get to Rails, we're going to have an object relational mapping, and it's going to happen automatically for you, and you're never going to have to think about this again. Until you're on a different platform and you're faced with this problem, and you're going to go, oh yeah, Professor Smoker said never do max to find the last value because it sets me up for a race condition. All right. I hope this helps with homework 5. It is a brand new homework, which is why there's some bugs and some issues with us getting it through. I wanted to introduce some concepts for you. Also not to be too big, because I know you have a bunch of midterms this week. All right, I hope that helps a lot. All right.